Hi guys, today we're going to continue our discussion about the first law of thermodynamics. Okay, so this is the second part of our video about the first law of thermodynamics. So basically, this is the last discussion about the concept, then we will proceed to our calculations. Okay, so in this video, we're going to talk about the mechanism of the energy transfer, the thermodynamic system, which we already discussed in our previous video, but we will have review on this topic before we proceed on the application of the first law of thermodynamics. So we will be discussing this equation right here because in some references you will find that the equation for the first law of thermodynamics is delta U is equal to Q plus W, while some references is writing this as delta U is equal to Q minus W. So we will discuss the difference between these two equations, and we will apply that by answering some examples. Okay, so we have two examples here that we will be using both equations. Delta U is equal to Q plus W and delta U is equal to Q minus W. Okay, so we have two questions to answer in order to understand this clearly. Okay, so let us now proceed to our topic and we will be discussing this in more details. Alright, so we learned from our previous video the concept of the first law of thermodynamics, which is basically the restatement of the conservation of energy principle, which says that energy cannot be created or destroyed but can be transferred into various forms. So if you haven't watched that video until now, so I would suggest to watch that video first in order to have a clear understanding on the concept of the first law of thermodynamics before proceeding to our lecture here. Okay, so we know that energy can be transferred from one form to another. So let us start discussing about the mechanism of the energy transfer. So we already seen this diagram in our previous lecture. So we have here our system, and outside our system is our surroundings. Now, since energy can be transferred into various forms, take note that energy can be transferred to or from a system in three forms. It can be in a form of heat, work, or mass flow. Okay, so let us start with heat. When our system absorbs energy from the surrounding in a form of heat, the energy within our system will increase because it accepted heat from our surroundings. So that is what we call heat gain. Now, if an energy is released from the system going to the surrounding in a form of heat, we call that as heat loss. So this is how energy is transferred from the system to our surrounding. Now, how about in a form of work? Now, we can discuss more about this later in our video because we are going to show you our calculation for the first law of thermodynamics. So, when work is added from the surrounding to the system, it will cause the internal energy of our system to increase because it receives work from our surrounding. And at the same time, if the system has done work to the surrounding, then we will have here a decrease of energy sa ating system because it's providing energy to the surrounding. And also we have to take note that energy can also be transferred in a form of mass flow. Now, mass is carrying energy within itself. So when mass is transferred from the surrounding to the system, the energy within the system will increase. And the same way, when a mass from the system is released to the surrounding, there will be a decrease on the energy in our system because the mass removed is carrying an energy within itself as well. Okay, so that is what is happening here between our system and surrounding. Now, as you can see dito sa ating diagram, there is a movement of energy and mass between the system and the surrounding. If you will recall in our previous video, this one, which is the thermodynamic systems and control volume, we discussed a lot about these thermodynamic systems. So if you haven't watched this video, you can check on our playlist and click on this topic to learn more about our thermodynamic system. But anyway, for this video, we're going to have a quick review of these systems. First, we have the open system. So what do we mean by the open system? In the open system, the transfer of mass as well as energy can take place across its boundary. So, anong ibig sabihin yon? Dito sa ating open system, mass can flow from the system to the surrounding or from the surrounding to the system. The same way, energy can also be transferred from the system to the surrounding or from the surrounding to the system. So, our mass and our energy can freely cross our boundary. So, wala tayong restriction dito in the transfer of mass and energy. Now, how about for closed system? In the closed system, we have a fixed amount of mass, and there is no mass can cross its boundary. That is, no mass can enter or leave a closed system. Okay? So, therefore, dito sa ating closed system, hindi nagpa-pass through yung ating mass from the surrounding to the system. So, okay, our mass cannot pass through. The same way, yung mass ng ating system cannot also cross the boundary. Okay? So, there is no transfer of mass between the system and the surrounding. However, for our energy in the form of heat or work, it can cross the boundary, and the volume of the closed system does not have to be fixed. Okay, so energy can cross our boundary dito sa ating closed system. So, tatandaan natin, sa closed system, energy lang ang may kakayanan na mag-cross ng ating boundary. Our mass cannot cross our boundary. Okay, so dito sa ating open system, there is no restriction. Mass and energy can cross the boundary. In closed system, energy can cross the boundary, but mass cannot cross the boundary. So as you can see, since energy can be transferred, therefore, the volume of our system can also vary. So kapag closed system tayo, it doesn't mean that the volume is constant. Okay, so we have to remember that. Now, what do we mean by isolated system? When we have an isolated system, neither the transfer of mass nor the energy takes place across its boundary with the surrounding. So, dito sa ating isolated system, yung mass natin is not crossing our boundary. Okay? So, mass cannot pass through as well as the energy cannot pass through our boundary from the surrounding to the system. The same way, from the system, mass cannot pass through and energy cannot pass through. Okay, so yan ang pinagkaiba ng three thermodynamic systems natin. Open system, no restriction, nakakapasok yung mass and energy. Closed system, nakakapasok ang energy pero hindi nakakapasok ang mass. And in isolated system, hindi nakakapasok parehong mass and energy. So, it's important to know the differences between this thermodynamic system because in some of our problems, we will encounter these terms. No? Kapag ang given natin is sinabing isolated system, therefore, there is no transfer of mass and energy. Kapag sinabi namang closed system, merong transfer of energy but there is no transfer of mass. So, we have to be aware of this thermodynamic system. So, now, let us apply the first law of thermodynamics, which we said it states that energy cannot be created or destroyed but can be transferred into various forms. So, let us have again our system and surrounding here on this diagram. And in our system, we have these atoms or molecules inside. Okay, so we know that our system have an internal energy. So when we say we have internal energy here, it is actually mean the all energy in the system. Okay, so we have all the energy in our system as our internal energy. Sabi natin, it's composed of all the energy in our system. So, it can be kinetic energy, potential energy. So, those energy are present here in our system. Okay? So, yun ang tinatawag nating internal energy. Now, sabi natin, energy cannot be created or destroyed, but can be transferred into various form. Okay? So, that means our internal energy can change. Diba? Katulad nung nakita natin dito. Kasi, our surrounding can affect the energy within our system. Okay? Mass and energy can be transferred from the surrounding to the system in an open system. And in closed system naman, energy can transfer. So, therefore, our internal energy can be changed. And that is what you are seeing in textbooks as delta U, which means the change in the internal energy. Okay? So, internal energy is written as capital U. Okay? Our delta U means the change in internal energy. Okay? So, sabi natin, our internal energy change. So, how it will change? If we have an isolated system where energy cannot pass through our boundary and mass cannot pass through our boundary, so there will be no change in our internal energy. But if we have an open system or a closed system where energy can cross our boundary, so there is a possibility for a change in internal energy. Okay, katulad nung sinabi natin kanina, it can be because a heat is added to the system, or heat is released from the system, or probably a work is done on the system, or work is done by the system. So, if these things happen, we can expect that there will be a change in our internal energy. That is why you can see in our textbooks that the change in internal energy is equal to the heat that is either added to our system or released from our system, and work, which is either done by the system or done to the system. Okay, now we have to talk about this equation, because in some textbooks you will see that this is delta U is equal to Q plus W. And on some textbooks you will see that delta U is equal to Q minus W. Okay, so this is how they write the first law of thermodynamics in different textbooks. May mga textbook tayo nagsusulat ng delta U is equal to Q plus W. Meron din naman nagsusulat ng delta U is equal to Q minus W. And this is really confusing. Okay, because you really have to identify kung ano yung gagamitin mo dito, no? Kasi pag nagkamali ka ng sign, imbis na positive, ginawa mong negative, of course, you will arrive to a wrong answer in your solution, no? Sa pagsasagot mo ng yung mga exams. So, it's important to understand how to use this equation. Because you can use either of the two. Pwede mong gamitin to at pwede mo rin gamitin to. You should arrive to the same answer as long as you understand what you are doing or how you are using these equations. So, how these equations differ, no? So, our delta U is of course the change in our internal energy. If our internal energy is increased, okay, so let me write that here. Let's say nag-increase yung ating internal energy. Dalawa lang naman yung possible na naging cause kung bakit tumaas yung ating internal energy. It can be because our heat increased dahil we receive a heat from our surrounding. Or it can also increase because we receive an energy from the surrounding in a form of work. Diba? So the same way, kapag bumaba ang ating internal energy, let's say here, our internal energy decreases, so possibly we lost heat, okay, in our system. So we give off heat from the system to the surrounding, or it's possible that the system has done work on the surrounding. So those are the possibilities. Okay? So the point is, since energy cannot be created nor destroyed, so kapag bumaba yung ating internal energy dito sa system, hindi yun mawawala. Mapupunta lang yun dito sa surrounding in a form of heat or work. Okay? So now, let us discuss how are we going to analyze this equation. Meron tayong dalawang equation dito, no? Identify natin yung pinagkaiba nila. So, we are having these differences in sign just because we are looking on it in a different perspective. Okay? Halimbawa, itong delta U is equal to Q plus W. We are telling here that there is a change in internal energy. Now, we have positive Q in here because we are accepting heat. Okay, so let me write that here. We are accepting heat. Now, we have positive W here because the work is being done from the surrounding to the system. Okay, so we have here our system is accepting work. In many textbooks, you can see that in here, it says that work is done on the system. Kapag positive ang ginamit natin dito, we are referring to W as work that is done on the system. So, ang keyword natin dito is yung on the system. Ibig sabihin, yung work ay nanggagaling sa surrounding. So, kung yung work ay nanggagaling sa surrounding, papunta sa system, since ang tinitignan natin is yung ating system, our concern is our system, naka-receive siya ng work from our surrounding, so therefore, there is an increase on energy in a form of W because he received work. Also in here, our Q is positive because he received heat from the surrounding. Diba? So kapag ang system natin naka-receive ng heat, it is positive. If our system receive work from the surrounding, it is positive. Now, kapag meron tayong delta U is equal to Q minus W, so in here we also have Q as positive. So wala tayong masyadong confusion dito because it's positive since it is accepting heat. The same lang, no? Pero why we have W in here? Negative, no? Bakit negative yung W natin dito? Because now we are looking on it in the perspective of the surrounding. Dito, makikita natin sa mga textbook, it's written that work is done by the system. Okay? So, by the system, it means, ang gumagawa ng work is yung system. So, kung yung system natin ang gumagawa ng work, that means, lumalabas yung ating energy in a form of work papunta sa ating surrounding. So, therefore, dahil nababawasan yung ating energy in a form of work, we will have negative value in here. Okay, so, it's just the difference in perspective. Para hindi natin ito makalimutan, in here, the doer of the work is the surrounding. Okay, so yan lang ang tatandaan ninyo dyan. Kapag positive yung ating W, ang gumagawa ng work is yung surrounding. Now, kapag negative ang ating W, the doer of the work is the system. Okay, so ganun lang naman ang ibig sabihin nun. You have positive here because our system is receiving work from our surrounding. You have negative W because our system is releasing work to our surrounding. Okay, so maiintindihan natin yan by giving you examples, okay? Okay, so let us have our first example. So let's say this is our system. Okay? So, meron tayo dito mga atoms or molecules. So, ito yung ating system. And then we are told that there is no change of internal energy. Okay? So, walang nagbabago dito sa ating internal energy. And we are also told that the system does 10 joules of work. Okay? So, our system done 10 joules of work. So, tandaan natin, there is no change of internal energy. Okay, so ang question natin is, how much heat is added or taken away? Okay, so hindi natin alam kung nadagdagan ba tayo ng heat or nag-release tayo ng heat. So, yan ang tinatanong sa atin. So, we have here our system. Alright. So, let us analyze our situation here. There is no change of internal energy. Okay? So, sabi, the system does 10 joules of work. Okay? So, it means it is our system who did the work. Okay? So, ang system ang gumawa ng work. Hindi yung surrounding ang gumawa ng work and in-apply niya dito sa ating system. It is our system who did the work. So, therefore, our system released energy in a form of work, which is equal to 10 joules. Diba? Now, according to the first law of thermodynamics, energy cannot be created nor destroyed. So, nag-release tayo dito ng 10 joules ng energy. So, dahil nabawasan yung energy ng ating system, therefore, our internal energy should reduce, no? Should also decrease in energy. Pero, sabi dito, there is no change on the internal energy. So, how that happened? Isa lang ibig sabihin yan, we also receive energy from the surrounding. And we receive that in a form of heat. Okay, so palagay ninyo, how much heat energy is added from the surrounding to the system para walang pagbabago dito sa ating internal energy. So, it will just be equal to 10 joules. So, para lang tayo ditong gumagawa ng energy balance lang naman, di ba? So, kung nag-release tayo ng 10 joules, dapat may pumasok na 10 joules dahil walang nagbago sa ating internal energy. So, let us use our equation kasi yan ang gagamitin natin dahil nalilito tayo kung positive or negative ba yung ating W. So, first, gamitin natin itong equation na to. We have delta U is equal to Q plus W. So, tandaan natin, ang sabi ko nakaraan in here, the doer of the work is the surrounding. Kapag ka-positive ang ating W, the doer of the work is the surrounding. Dahil, yung surrounding natin ang gumawa ng work papunta sa system, so therefore, nagdagdag ng energy dito sa ating system. So, our system receive energy from the surrounding in a form of work. Okay? So, in that case, our delta U is equal to 0, di ba? So, 0. Now, our Q, hindi natin alam dito kung ano yung ating Q, di ba? Yan nga yung question. How much heat is added or taken away? Then, plus our W. So, sabi natin, W, on this case, the doer is the surrounding. Okay, so, nakikita natin dito, no? Yung doer natin dito ng ating work is hindi naman yung surrounding. Ang gumawa ng work sa atin dito is yung system. So, this does not apply. So, taking the perspective to our system, did our system gain energy in a form of work? No. Okay, so dapat yun ang case natin kapag positive W. Our system will receive energy in a form of work from our surrounding. But in this case, we did not receive energy from our surrounding in the form of work. It is our system who did the work. So, nag-release siya ng work. Okay, our system released work. So, therefore, dapat negative to because we released or we lose energy in a form of work. So, we have negative 10 joule. Okay? So, what will be our value here? We have 0 is equal to Q minus 10 joule. Okay? So, transposing this to the left side, we will have Q is equal to 10 joule. Okay? So, that means, nakikita ninyo dito sa ating answer, positive yung ating Q because our system received 10 joules of energy in a form of heat mula sa ating surrounding. Okay? So, positive because our system received heat from our surrounding. Okay? So, tignan naman natin, gamitin naman natin itong delta U is equal to Q minus W. So, ang sabi natin, kapag yan ang gamit natin, our doer is the system. Okay? Kapag Q minus W, doer of the work is the system. Okay? So, sabi natin, in here, our delta U is 0. Hindi natin alam yung Q kasi yan ang tinatanong sa atin. Did we add or it's taken away? Okay? So, minus W. So, sabi natin, kapag minus W, the doer is the system. Okay? So, dito ba sa ating diagram, sino ang gumagawa ng work? Who did the work? It is our system. It is the system who did the work. So, ito yung sinasabi sa textbooks as the work is done by the system. Okay? So, in that case, dahil ang doer natin is yung system, therefore, positive ang ating W. So, we have plus 10 joule. Okay? Because, tama. Doer natin dito is yung system kapag minus W. And it is correct here. Our doer is our system. So, positive ang ilalagay natin dyan. So, therefore, we have 0 is equal to Q. Negative times positive will be negative 10 joule. Okay, so transposing that to the left side, we have Q is equal to positive 10 joule. Okay, so ganun lang yon. Now, to understand this further, gawa ulit tayo ng isa pang example. Ano? Kasi mas maganda maintindihan natin talaga because maraming nako-confuse. They will use positive or negative dito sa ating equation. Now, let us have our second example. Okay, so again, gayahin lang natin yung kulay para hindi tayo ma-confuse. We have again our system. Okay, so we have our particles here. This is our system. And then dito sa ating problem, it's stated that 6 joule of heat, okay, is taken away from the system. And then, sabi rin dito, we have 2 joules of work is done on the system. Okay, tandaan natin, 2 joules of work is done on the system. Therefore, ang gumawa ng work is yung surrounding because it is done on the system. Kapag sinabing done by the system, yung system ang gumawa ng work. Pero sabi rito, done on the system. So, ginawa yung work ng surrounding sa ating system. So, 2 joules of work is done on the system. And then, our question is, what is our change in internal energy? So, mag-analyze muna tayo ng ating mga given. Sabi, 6 joules of heat is taken away from the system. So, we lost heat, okay, in our system. So, 6 joule of heat is taken away. Okay, so we have 6 joules. So, ayusin natin ang pagkakasulat. So, we have 6 joules of heat taken away from our system. So, we lost 6 joule of heat. Okay? But, 2 joules of work is done on the system. So, yung surrounding natin ay nagbigay ng 2 joules of work dito sa ating system. Okay? So, in the form of work, we have 2 joules from the surrounding to the system. So, nagkaroon tayo ng change sa ating internal energy. So, gaano karami yon? So, sabi ko nga, para lang tayo nagma-material balance dito or energy balance, no? So, dito pa lang makikita na natin. May lumabas na 6 joule, which is negative 6. May pumasok na 2 joule, which is positive 2. So, negative 6 minus 2 will be negative 4 joule. Okay, so from here, makikita na kagad natin yung ating balance. Because, according to the first law of thermodynamics, energy cannot be created nor destroyed. Okay, so, nag-change lang siya ng form or can be transferred from one to another. Okay, so pag may lumabas na 6, tapos may pumasok na 2, so ano yung magiging energy ng ating system? Our internal energy will change negative 4 joules. So, gamitin natin yung ating equation, ano, para malinawan tayo. So, we have delta U is equal to Q plus W. And katulad nung sinabi natin kanina, no? If we have, or if we are using plus W sa ating equation, the doer of our work, okay, is the surrounding. Okay, so ang doer ng work is the surrounding kapag W is positive. Okay, so hindi natin alam kung ano yung delta U. What is Q? So Q is positive kapag our system is receiving heat, negative if we are losing heat. So in here, our system is losing heat, okay, because the heat is taken away. So therefore, our Q is negative here. So we have negative 6 joule. Then we have plus our W. Ang tanong, what will be our W? If we are using this equation, the doer should be the surrounding, okay? So as you can see, is it our system who did the work? Kasi kung yung system ang gumagawa ng work, our direction will be the other way around. Our system giving energy in a form of work to our surrounding. But in this case, our surrounding is providing energy in a form of work dito sa ating system. So, here it conforms that the doer is the surrounding. So, therefore, we will have positive here because, yes, the doer here of work is the surrounding. So, we have positive 2 joule. Okay? So, now we have delta U is equal to negative 6 plus 2, which is negative 4 joule. And this is our final answer here. Okay? So, again, gamitin naman natin yung susunod nating equation, which is delta U is equal to Q minus W. Okay, so sabi natin, if we are using this equation, the doer of the work, ang doer natin dito is yung system. Okay? So, ito yung done by the system. The work is done by the system. Okay? So, we don't know what is delta U. So, yan ang hinahanap natin. We have delta U is equal to Q. So, Q is positive if our system is receiving heat, and it is negative if we are losing heat. So, as you can see here, our system is losing heat. So, therefore, we have negative 6 joule here. Now, minus, what will be our W? Sabi natin, in this equation, the doer is the system. Now, is the doer of the work is the system? No, because it is receiving work from the surrounding. So, kabaliktaran. So, imbis na ang system natin ang gumagawa ng work, our surrounding is providing energy in a form of work sa ating system. So, positive siya kung yung system ang gumagawa ng work. But since our surrounding is giving work, therefore, we will have negative 2 joules here because it does not conform to this. The doer of the work is the system. No, because the doer of the work is the surrounding. Okay? That is why negative yung ating naging value here. So, therefore, we have delta U is equal to negative 6 joule. Negative times negative will be positive 2 joule. Okay, so therefore, delta U is equal to negative 6 plus 2, negative 4 joule. Okay, so as you can see, kahit anong equation ang gamitin natin dito, whether you use delta U is equal to Q plus W or you use delta U is equal to Q minus W, you should arrive on the same answer. Ang magiging batayan lang natin dito is if we are using this one, you should understand that the doer of the work is the surrounding. And if you are doing this one, you should understand that the doer of the work is the system, okay? For me, the easiest way is to use this one, in my own opinion, because it is easy to understand. We just need to take note always in the perspective of the system. Delta U is equal to positive if we are receiving heat from the surrounding, and positive W if we are receiving work from the surrounding. So, pareho lang siya ng case ng Q, no? If the system is receiving work, it will be positive. If the system is receiving heat, it will be positive. So this will be easy to understand, but you will see this also in our textbook. So I hope this is clear for us right now, and I hope that it helps you in your studies. So that's all for now. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa engineers.org.